Hey, this is Dr. Green. We're working on WebAssign Homework 7, Problem 17. We've got a little bit of CSI going on here. We are doing some forensic psychology. We are trying to correlate age of criminals and age of victims in a linear relationship. So that's called a least squares line or a regression line that we're trying to find. That's what they want in Part A. The steps to do that in SPSS, and that is the way that we'll do it. You can do it with formulas. We'll look at formulas in a later problem, but basically what SPSS is doing for us when it finds the line is if you graph the scatter plot of the data here. Say this data looks like this. We've got the age of the criminal down here and the age of the victim up here, and we've got those 5 data points. And we want to find a line that kind of best estimates those points, so that might look something like this. And the way that we find that line is we look at the vertical errors from the points to the lines, and we square all those errors to make them all positive, because some are overestimates and some are underestimates, some are above the line and some are below. And then we add up all the squared errors and we minimize them. And when we do that minimizing, we get the least squares formulas. And if you go to the exam 3 formula sheet, you'll see regression line here. Y equals y hat, actually, because it's an estimating line, is b times x plus a. So b is your slope, and the slope is the sum of squares of xy over the sum of squares of x. So this is the sum of squares in xy. Remember, that tells the variation of x with y. And then this is the variation in x. And then the y-intercept, that a coefficient, is the mean of the y values minus b times the mean of the x's. So those equations come from trying to minimize the squares of these vertical errors on the line. So with that in mind, we're going to use SPSS to compute those values b and a, the slope and the y-intercept of the line. So we're going to enter the data in the first and second columns. We're going to do analyze regression linear, move our variables over into the independent and dependent spots, and then click OK. So here is that data in SPSS. I've already entered it in. Age of the criminal here, and then age of the victim here. So both scale variables. Nothing special, don't have to define anything. Analyze, regression, linear. Then we think that the age of the victim depends on the age of the criminal. So the age of the criminal is going to be our independent, and the age of the victim is going to be our dependent. So age of the criminal is our predictor variable, and then the age of the victim is the criterion variable. Click OK. And then we'll see 2 things here, variables entered or removed. So we really don't need much that's in there. It's just telling us the dependent variables, the age of the victim, and the independent's the age of the criminal. We see the model summary here, and that tells us r and r squared for the correlation. And then here we see an ANOVA. Notice down here that the 0.04 is less than 0.05. That's significant. But the table we're interested in is the coefficients right here. So let's copy that table and bring it back over to our document. And that's right here. So what we see here is the constant, 10.859. That's the A. So that's the constant. And then the slope is the b, and that coefficient is here. So our a is right here, and our b is right here. And then our significance level for the test is right here. That's a p-value. So those are the important numbers in the coefficients table. So let's go ahead and write out this y-hat equation. So our b is 0.552. So the y-hat value is 0.552 times the x plus 10.859. So now we want to use that regression equation to determine the predicted age for a victim of a nonviolent crime when the criminal is 40 years old. So this is saying that x equals 40, and then the predicted age is going to be that y hat. So the y hat value then is going to be equal to 0.552, and then we take x equals 40 and plug it in, and then add on the 10.859. And if you key that into the calculator, you will get 32.939. So approximately 33 years old is what we could predict for the victim's age. So that's part A and B. And then part C, and I'm actually kind of combining some things from a couple of different problems. I think in one problem they have you do part A and B, and another problem they have you just do B and C. So in part C, they want us to compute the analysis of regression for the hypothetical study, and then round to 2 decimal places. So they want us to fill in an F table here. So this Anova table I got from the output in Spss. So that again is just above the coefficient. That's right here. So that Anova table. And that's what I've brought over right here. So we see all the numbers that they want for us. We've got a sum of squares column, a degrees of freedom column, a mean square, and then an F column, just like when we were doing ANOVAs in the earlier chapter. So let's go ahead and transfer that information over. So there the information is transferred over, and here they want us to make a decision to either retain or reject the null hypothesis. And here we see that our F statistic is 0.04, and that is less than 0.05. No, I'm sorry, I transferred the wrong variable here. The 0.04 is our p-value. The F statistic is the 12.219. So if we didn't have SPSS, we'd look up in the back of the book the critical value for this and compare it. But here in the ANOVA, we've got a p-value, and that p is less than 0.05, which is the level we're testing at. Okay, we assume alpha is 0.05, so we're less than 0.05, so we are going to reject the null hypothesis. So again, the null hypothesis is going to say that these two variables are not linear related, and the alternative hypothesis will be that they are linearly related. Okay, so so at the 0.05 level, we are confident of this equation.